Hello, workplace math students. In this video, I'll be introducing the concept of trigonometry. And in particular, in this unit that we're going to be starting in trigonometry, I will be talking about Pythagorean theorem today. So there will be two sections to this, and this is the first section, part one, Pythagorean theorem. So I'll be working through with you to help you understand how to do the initial assignment that you should have seen posted. So in your workplace Math 10 Google Classroom, you should hopefully have seen a 7.1a Pythagorean Theorem assignment. And so it should look something like this. In here there is quite a bit of detail, and you'll see that there are some files included here. This is basically like as if I had done some lecture notes for you on the whiteboard. You can review this. There is a demonstration file that I'm going to be going through in a moment, so you can reference this here. And then when we talk about mathletics, there is a user guide here that you can get some more information on how to use that particular program. So getting it right into it, I just want to look at trigonometry here. So if we scroll up to the very top here and look at this document, when we talk about trigonometry, we're talking specifically about two key concepts. One is this concept of square. And so a reminder that a square is simply in math a number that is multiplied by itself. So in other words, if I took 5 and I multiplied by itself, it would make 25. Another way of saying this is actually to put a square sign, this symbol here, 5 squared, which is also equal to 25. Now, another key concept that you need to understand is what a right triangle is. So a right triangle is basically defined as a triangle with a 90-degree angle. So in this case here, if you look at this, this line here is indicating that this is a 90-degree angle within a triangle. And when we have this, there is a term that is used for this. And one of the things that we see here is that in any right triangle, the side that is directly opposite, in other words, we were to have this, if we look at this thing here and go directly opposite, this is the hypotenuse. This is the longest side of any right triangle. And then we have the two other sides, and they are collectively called the legs. And basically, when we talk about Pythagorean theorem, we talk about a squared plus b squared equals c squared. And the legs are either the A or the B, but they're either A or B, and it really doesn't matter which one we define as A and which one we define as B. But the key is the hypotenuse, which is the longest side, is always the C. So I'm just going to erase that off here. Basically, looking at this, we need to then look at the Pythagorean theorem itself. And so if we look at Pythagorean theorem, you may remember this from previous classes, this idea of A squared plus b squared equals c squared. And what we are actually saying here is when we talk about square, we're talking about actually physically looking at what would happen if we were to square a particular side. So if I were to take the perfect square or make a square out of this side, it basically makes this shape here, you hopefully can see. And if I were to take 8 and I were to multiply it by itself, it makes 64. Likewise here, if I were to make this square here, and I were to take the 6 and multiply it by itself, it makes 36. And then these two numbers, 64 plus 36, 64 plus 36 is what is going to add up to the other square. So this here is going to add up to this 100 here. And this 100 is the square of the longer side, the hypotenuse. And remember, the hypotenuse is always directly opposite the right triangle. So I'm just going to erase that off. And what we're trying to say here then is this. So hopefully this makes sense, but basically in words, what I'm saying to you is that the sum of the area of the squares attached to the legs, that's so 64 and 36, is equal to the sum of the square attached to the hypotenuse. So 64 plus 36 makes this 100. So that's basically the concept of Pythagorean theorem. Now, to review some of what we just discussed there, if I were to try and say to you this sentence here and fill in the blanks, it says in a blank triangle. And the reality is it's not every triangle, it's only in right triangles. So it's a right triangle I'm trying to write with a mouse, which is hard, but in a right triangle, the sum of the areas of the square attached to the legs equals the area of the square attached to them. This is a key term, the hypotenuse. So please remember this term. The longest side of a right triangle, the one that is directly opposite the 90-degree angle, is the hypotenuse. And I'm having trouble writing that, but you can get the idea. So I'm just going to erase that here and then move down to the next concept. So the next concept basically is here. So if we were to label the hypotenuse of this triangle with a C and the other legs with an A and a B, and then draw a square and then write the relationships, basically it would look something like this. So if I were to label the sides, because this is directly opposite the right angle, this is the C side. And I could label these, either this could have been a B or an A. I'll just choose to make that one the A, this one the B. It really doesn't matter. And then if I were to draw the squares there, essentially what I'm saying is I'm drawing a square that, and obviously that's not a perfect square, but I'm doing the best I can here, and a square here, and obviously the hypotenuse square is going to be larger. And then the relationship between this is that A squared, in other words, the square of that, and B squared, those two collectively is going to make up this C squared. So hopefully that makes sense to you. So I'm just going to erase this off here again, and let's take a look at the next sort of step in this whole process. So here, looking at this example here, if we were to have this here example, what would the areas of these be? Well, let's take a look. So basically 8 times 8, or 8 squared, is going to be 64. And that is the hypotenuse that we're saying. We're assuming it's a hypotenuse. 6 times 6 is 36. And 5 times 5 is 25. Now, realistically, if this were an actual right triangle, this were 90 degrees, and we don't know if it's 90 degrees, but if it were, then 25 plus 36 should add up to 64. But in reality, 25 plus 36 does not add up to 64. It adds up to 61. And that's not what this matches up with, so therefore it is not a right triangle. So hopefully that makes sense. So let me just erase that off here. And let's take a look at the next sort of concept in this whole steps here. So looking here now, if we had to calculate the missing areas of each square, how would we do that? So let's take a look at this here. So once again, the right angle here in this case is right here. So this is the hypotenuse. This is the largest side. So what we need to do is we need to take these two squares, one of which is 10 centimeters squared and the other is 17 centimeters squared. So we're going to take the 10 plus the 17, and that's going to add up to what the hypotenuse square should be. So we're saying that this hypotenuse square should be 27, and that is centimeters squared. Okay. Now over here though, this is the hypotenuse here. So this is the hypotenuse, this is the big side. And so this and this have to add up to this. So the way we would figure this out is we would take the 500, which is the full largest size, and subtract from that 400. And so what that's going to give us is what we have left over, which is, and this would be 100 centimeters squared. And I don't think I can fit centimeters squared in there right now, but you get the idea. So I'm going to erase this off here, and we'll look at the last of these sort of steps here. So looking down at the next question, it says determine the area of the square that would be attached to the hypotenuse for these two right triangles. So let's take a look at how we can do that. So what we need to do here is we need to firstly consider that we have a square here and we have a square here, but these two are the legs. and that the hypotenuse, which is directly opposite the right triangle, is going to be the biggest of the squares. And I'm just going to try to draw this as best I can. So 17 times 17, if we were to plug that into our calculator, is going to be 289. And likewise, if I plug in the calculator 26 times 26, this is going to be 676. So if I then added these two together, 289 and 676, then what the area of this square would be the adding of those two, which is 965. Now, what we're going to talk about a little bit later, and I'm just going to add this as a concept right now, if we were to take the square root of 965, what we end up with is a number that is 31.06. So I'm going to just write 31 there. But what we can see is this makes sense because the hypotenuse is the longest side, and 31 is clearly longer than either of these two legs, 17 or 26. So let's take a look at this one over here now. So the hypotenuse, once again, is over here. This is the longest side, so we're expecting this square to be the biggest square. These squares should be much, well, not much, but smaller. And if I were to take 15 times 15 to figure out the square of this, this is 225. And that would be centimeters squared. I won't bother writing that in, and then this is 7 times 7 is 49 centimeters squared. So this 275 plus 49 is going to add up to 274 here. So this is going to be the bigger square. And if I were to take the square root of this, that's a square root sign, then I find out that this is approximately 16.6. Which makes sense once again because it's the biggest side, so therefore 16.6 needs to be bigger than either of the legs, 15 or 7. So I'm just going to erase this off here. Got a lot of writing I have to erase, but once I got that erased, I'm just going to then move down here, and I'm going to talk to you a little bit about mathletics now. So we have, up to this point, been working with worksheets and then you having to take pictures, which is a little bit cumbersome for some of you. So what I've tried to do is find an online program, and this is called Mathletics, that we can use instead to do your assignments, and then I can track how you're doing with your questions. So what I'm going to do is I'm just going to click over here to Mathletics now for a moment, and I'm just going to show you what this would look like. So I have sent an email, or sorry, I've posted a message to each of you individually that tells you your username and your password for Mathletics. So once you click on the little link, this should take you to mathletics.com, and then we can click on sign in here. And then in here, you're going to put your username up here and then the password down here. And then when you click in and sign in, what you should see is a screen that looks similar to this. It might be a little bit different because I've come in here already before. But basically what you're going to see is there's going to be two assignments that are assigned to you: the hypotenuse of a right triangle and the Pythagorean theorem. So if we were to click on, let's say, the Pythagorean theorem right here, what we're going to see is we're going to see a question that looks like this. And so then your job would be to answer this. So the very first thing they're asking for here is they're basically asking what is the square of this x here. And just so we're clear, so we're talking about the square, we're talking about x squared here. We're asking what that is. But remember that in this case, because the right angle is here, this is actually the hypotenuse. So this is going to be a smaller number, x, than this 17. But what we're looking for here is we're going to be looking to solve this. Now, if you are not sure how to do this, and I'm going to walk you through how to do this, but if after everything I talk about, this does not make sense to you, what I would suggest you do is in Mathletics, there's this wonderful tool here that looks like this. It's an eye tool. So if we click on this, what it will do is it will take a look at a similar type of question and it will step you through here. So you can press there and it will kind of walk you through how you would do this, how you would solve it, and it will walk you right through and kind of explain to you the process for solving a question like this. So essentially what I'm saying here is that this program is designed to actually physically walk you through this entire step. So this is a wonderful sort of feature in here that you can use. And then you can backtrack and take a look at this as many times as you want. But basically that will help you. So I'm just going to jump back over here now and take a look at a print screen of one of the questions you're going to see in that Pythagorean Theorem assignment. So imagine we have a question like this, and we are looking to solve for x, well, x squared and x. So basically what we have to do here is we need to firstly figure out what x squared is. And one of the things we need to recognize here is that in this case here, this is c, 40 is c, and I could define 24 here as a, and then x is ultimately going to be, in that case, if I could define that as a, this is b. So in this relationship of the Pythagorean theorem form of a squared b plus b squared equals c squared, if I know that a equals 24, b equals x, and c equals 40, I just literally physically plug in those numbers into the formula. So I'm just plugging in the red here, number in for what I know. And when I do this, 24 squared once again means 24 times 24. When I do that use a calculator, I get this value here. And then likewise, 40 squared, I get this value here. Now, in case you're not quite clear on this, I'm just going to quickly show you this. So if I were to just change my screen to my calculator here, what we are going to see here is that on a calculator on a computer, one of the buttons you have an option to change view from standard to scientific, which is what I'm looking at here. And if I wanted to know what 24 squared was, I can click 24, and then here is the square button right here. So 24 squared is 576. And likewise, if I wanted to figure out what 40 squared is, I go 40 and then press the square button here to figure out that that's 1600. Okay, now if I look at my steps here again, one of the things I have to do is if I want to get x squared by itself, I'm going to have to subtract 576 from both sides. So if I do that, I'm going to have to figure out what 1600 minus 576 is. And when I plug that in my calculator, I'm going to get a value of 1024. Now, when I get that value of 1024, what I need to do is I need to take the square root of 1024, and this will, in my calculator, tell me that that value is 32. So I'm just going to stop share on this calculator screen and go back to my trigonometry screen here. But basically what we've done is we can see using the calculator that I was able to figure out that this value is 576 and this is 1600. I subtracted the 576, the a squared from the c squared to get 1024. And then when I took the square root of 1024, I found out this answer was 32. So to just clarify, what I would be putting into my answer here was, for here I would be putting 1024, because that is what x squared is. And then when I find x itself, it's a square root of that, which would be 32. So that's how I would answer that question. So let's take a look at another example, a similar example, but one that's going to be like the second assignment in mathletics. So this is an example here again, but in this case here, what we are looking at is we are looking to try and solve for what the hypotenuse is in this case. So what I mean here is I need to just get my writing tool here. So directly opposite of the right angle is h. So what we're saying here in essence is that h is equal to c here. And then I could define these however I want. I could say that this is side A, this is side B, but basically both of these are the legs. So this is going to be the longest side, side C, A and B are shorter. So if I plug those values, A equals 36, B equals 27, into my formula, I get this formula here. And then once again, using my calculator, using the square, 36 squared is 1296, 27 squared is 729. When I add those two numbers together, this becomes 2025. So now in order for me to figure out what the difference is here, I have to square root these. So that's why I have that step here. I have to square root this. And when I plug that into the calculator, the square root, I get 45. So let me just run that through with you, just using the calculator one more time. So in here, if I were to do this, once again, just watch how I can do this as well. I could actually go 36 squared and then actually plus and then 27 squared to get that 2025. And then I can take the square root there and get that 45 figure there. So if I go back to my main screen here again, the answer that I would have to put in here would be basically for h squared, I would be putting in 2025. So I'd write in there 2025 in mathletics. And then in h, it's the square root of that, which would be 45. So I'd obviously click the submit button in my mathletics, and then it would be done. So hopefully that makes sense to you. If you have any questions, please do not hesitate to email me back, and I can try and help you in whatever way you need to. Thanks for watching.